Greetings. This is the Lesson 20 homework. Lesson 20 is where we're really getting into two-step word problems that involve multiplication and division, and we're trying to assess the answers that we get for are they reasonable or not. Two-step word problems take a lot of work. They're a little bit overwhelming, but there's something that if we will take one chunk at a time, it becomes much more doable. Sometimes, though, what happens is the kids will read them. They will either become very overwhelmed and just throw something down, or they'll only answer part of it and they forget to go back and answer the second part. So it's important to talk to your children about slowly looking through and making sure you have answered all parts of the problem. So let's look at the top problem. The teacher has 12 green stickers and 15 purple stickers. 3 students are given an equal number of each color sticker. How many green and how many purple stickers does each student get? I will say my brain probably works in a very odd way. In fact, I'm quite sure of that. When I'm reading this question, especially when I was younger, I would wonder, do they want to know the total of the green and purple stickers that they get, or do they want to know the exact number of green, the exact number of purple? So we're going to find a way to answer both of those questions. What I know And what I know is typed in black and white. That's what I tell the kids. Look for what is typed in black and white. I know there are 12 green stickers, and I know there are 15 purple stickers. And I know that 3 students are sharing these because it says they're given an equal number of each color sticker. Now, let's work on the green stickers first. There are 12 green stickers being divided into 3 groups given to 3 students. The students are our groups, and they're sharing them equally. I need to know how many stickers each person gets. There's the division sentence that matches that. So often solving division problems is easier if we will flip this into multiplication. Because they are inverse operations, they undo each other. They're the opposites of each other. To make this into multiplication, we're going to write the sentence backwards and change the operation pretty much. Something times 3 equals 12. So I can ask myself, how many 3's do I need to get to 12? And I'm going to make a skip counting list. 3, 6, 9, 12, where I count by 3's because that's the factor that I know. I needed to count by 3 4 times. So I know each student is getting 4 green stickers. I might make a note under here. Now let's work on the purple stickers, and I feel like we should pick a purple color to do it. That feels like the right thing to do to me. So let's pick a purple color. What do I know about the purple stickers? I know that there are 15 purple stickers being shared by 3 students. What I don't know is how many stickers they each get. I'm going to take this and I'm going to flip it into multiplication. Some number of stickers times 3 students equals 15. And again, I'm going to count by the factor that I know. 3, 6, 9, 12, 15. How many 3's did it take me to get to 15? 1, 2, 3, 4, 5. Therefore, 5 times 3 is 15. 15 divided by 3 must be 5. So for the purple stickers, will that go away? Yes, it will. Okay. For the purple stickers, each person received 5. Now, if they're asking how many green stickers they get, you would say 4. How many purple stickers? 5. If they want a total number of stickers, we're going to combine 4 and 5 together. 4 plus 5 is 9. So each student got a total of 9 stickers. 4 were green, 5 were purple. And if you see, we broke this down and did this in a very neat and organized way, asking ourselves the whole time, what do we know for sure? What does the word problem tell us? Not what we think, what we're guessing, what we remember about being given green and purple stickers in first grade. I've had 5 purple stickers given to me. No, you can't pull out what you know about purple stickers in life. You can only go off what it says in the word problem. Okay, I'm going to erase this because I think that it might be a little bit less overwhelming as I do these problems if I have erased everything else on the page so that there's not so much being scribbled on there. So let me delete this and let's answer problem, maybe, problem 4. 3 friends go apple picking. Right away, I'm going to change that to a numeral because when numbers are written in word form, that's when kids forget them. They'll leave them out because they're used to seeing a numeral, numeral 3. 3 friends go apple picking. They pick 13 apples on Saturday and 14 apples on Sunday. They share the apples equally. How many apples does each person get? Okay, again, we have to ask ourselves, what do we know for sure? And let's make a model of that. I know that on Saturday, 13 apples were picked. I know that on Sunday, 14 apples were picked. I know that these apples in their entirety are going to be shared between 3 friends. To figure out how many apples each person gets, I need to first decide how many apples are there total. And so I need to combine the apples from Saturday with the apples from Sunday and get my total number of apples. Well, if Saturday is 13 and Sunday is 14, that gives me a total of 27 apples. My 27 total apples are being shared or divided between 3 friends. How many do they each get? Again, let's flip that into multiplication. 3 times something equals 27. What factor do we know? We know 3. We can count by threes and see how many threes does it take to get to our total of 27. So I'm going to make a running list over here. 3, 6, 9, 12, 15, 18, 21, 24, 27. How many threes did it take us to get to 27? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9 is 27. Therefore, 27 divided by 3 is 9. Each person got 9 apples. This is one of these where you're assessing for the reasonableness of your answer. I like to have kids write out their answer. Each person received 9 apples. When you write it out, you can oftentimes find if you have made a huge mistake, and this is the big mistake that happens the most. The kids may combine to find 27, and they may do 27 3 times. And so they're looking at, here I am doing public math. Oh, 81. If they were to write out each person received 81 apples, they would probably stop for a moment and say, or they would hopefully say, wait a minute, that's not a very reasonable answer. There are only 27 apples altogether. They can't have each received 81. Okay, so this is why encourage your child to write using a complete sentence what their answer is and reread it and ask themselves, does that make sense? Can they each get 81 apples if there were only 27 apples to start? No, they cannot. That's not reasonable. Okay, so that is that. They each got 9 apples. And again, take this slowly, one step at a time. What do you know for sure? And how do you get from what you know to what you're trying to find? I am going to erase this again. Perhaps will it erase? I will find out. And I'm going to work on the bottom problem. The store has 24 notebooks in packs of 4. 3 packs of notebooks are sold. How many packs of notebooks are left? Okay, this is going to take multiple steps to get to. Let's go back and label what we know. The store has 28 notebooks. That's a total. In packs of 4, That's the size of each pack. And then it tells us 3 packs of notebooks are sold. How many packs of notebooks are left? Well, I can't determine how many packs of notebooks were sold until I figure out how many packs they started with. So, what I know is there are a total of 28 notebooks, and they're being sold in packs of 4. So here's one pack. One pack of 4 does not give me 28 notebooks, it gives me 4 notebooks. So I'm going to need a second pack of 4. Now I'm at a total of 8 notebooks, and notice I'm going to keep a running list along the bottom to keep me organized and on track. Another pack of 4 will give me 12 total notebooks. Another pack of 4 will give me 16. Another pack of 4 will give me 20. Another pack of 4 will give me 24 notebooks. And another pack of 4 will give me 28 notebooks. That is a 4. Oh, that's a terrible 8. There we go. I've redeemed myself a smidge, but not much, I fear, with that 8. Okay, here's where the problem occurs. Typically, if kids get to this point, what they're going to do next is they're going to count their packs of notebooks. 1, 2, 3, 4, 5, 6, 7. And they're going to say, how many packs of notebooks are left? 7, because they're not going back and rereading the problem. We found that there are 7 packs of 4 that make up our 28 total notebooks. But we need to reread this sentence. 3 packs of notebooks are sold. Sold means given away. So let's mark out 1, 2, 3. 3 packs of notebooks are sold. And then to answer the question, how many packs of notebooks are left? Not how many total notebooks are left. How many packs of notebooks are left? I can look at my model that I've drawn that's very organized, and I see that there are 4 packs of notebooks left. And I'm going to write that in a complete sentence. There are 4 packs of notebooks left. Oh, that didn't show up. That's terrible. And when you look at this handwriting, don't you think to yourself, I'm so glad Miss Jackson doesn't teach handwriting because it looks terrible. I have the handwriting of the doctor, but not the paycheck. That's okay. Problem 5 is solved. Remember, we have to go slowly, ask ourselves, what do we know? What are we missing? How do we get between those two? And if you'll make a model, typically it's much easier to do without getting lost and confused. Okay, that is it for the Lesson 20 homework. On to, in the next video, Lesson 21. And isn't it a gem?